Good morning. Myself, Dr. S. Muthusundari. Today, we are going to discuss about the instruction set of 8051. 8051, which is nothing but microcontroller. As we are familiar with that, in our syllabus, we are going to discuss about the microprocessors and microcontrollers. Microprocessors, 8 is called as 8086, and a microcontroller, which is called as in the number of 8051. So, first 3 units, we have discussed about the microprocessor. And in the 4th unit, mainly we are going to focus on the 8051. That means microcontroller. In this 4th unit, we are going to concentrate on the microprocessor, microcontroller architecture, addressing modes, and then instruction set. So in that first, we are going to discuss about the instruction set of 8051. Definitely the instruction set which will help you how we are going to write that program in it, which is nothing but it is going to specify certain instructions, how these instructions are going to be represented in that particular 8051. So first of all, we can discuss how many instruction sets are available in the 8051. The instruction sets are grouped into 5 here. So which is called as arithmetic instruction set, logical instruction set, data transfer instruction set, Boolean instruction set, and branching instruction set. So first we will discuss about the arithmetic instructions. So first of all, we want to know what do you mean by arithmetic instructions? Already we are familiar with that. Arithmetic operations, we are very familiar. Either add operations can be performed, or subtraction, or multiplication, or division. Okay, these are the standard terms. So here we are going to discuss add operation, ADDC. The ADDC, which is nothing but add with carry. SUB stands for the subtraction operation. SUB B in the sense we are going to perform the subtraction with the borrow operation. So first we discuss the addition operation. The syntax for the addition is ADD is the command, and then A, comma, the source. The right hand side shows the source register and the left hand side shows the destination register. So here add A, comma, the source. So both will be added and finally the results will be stored in the destination. Okay. So either in the source we can give the operand directly, or we can give the register name also, like that. So add C. Add C in the sense we are going to perform the addition with the carry. So similarly the general format is add C, A, comma, source. So here the source may be either a direct immediate address or register or whatever it is that will be added with the carry value. Then again the results will be stored in the left hand side. So similarly we can able to perform the subtraction. SUB we can do, or similarly SUB B, subtract with the borrow. Again we can perform increment operation, decrement operation, multiplication, and the division. INC, the command stands for the increment. So automatically it will go for incrementing the operand by the 1. So similarly decrement, it is mentioned by the DEC command. And we can, it is decremented the operand value by the 1. And then for example, if previously the content value is 5, if you are going to use increment, then already 5 is there. So 5 plus 1, 6 will be produced. So decrement, if already DEC is 5, then after performing the DEC operation, your value will be stored as 4. Multiplication, mul AB. Then automatically A and B will be multiplied and the results will be again stored in the A register. Okay. So here both will be indicated by the 8-byte operation. So similarly, we can able to perform the DIV operation, division, which is going to perform the division operation. So here div A, B in the sense, A will be divided by B. At the same time, we have performed the, whenever you go for the division, we will be having 2 results. One is for the quotient and other one is for the remainder. The quotient will be stored in the A register. The remainder will be stored in the B register. Both are considered as the 8-byte of data. This is the example for the multiplication of the numbers. So the command is mul AB. So now here we are giving the data for A equal to 7 and B for the 2. Appa, what is the value? 7 into 2, 14 we have to get. Now the data which are being in the 16-bit of, then hexadecimal fashion in the sense, for here we will be having 0 to 9. After that, 10 and 11, 12, 13, that number will not be. Instead of that number, it starts with the values A, B, C, D, E, F. Okay. So 14 in the sense, we have to get that value as E. That is for the number 14. Okay. So similarly, division of the numbers also will be performed. Second, we will go on to the logical instructions. What do you mean by logical operations? The logical in the sense and operation, or operation, exclusive or, negation. These are all called as the logical operations. So here the syntax for the AND operation is ANL. And in the sense AN, L stands for the, it implies the logical operations. So and ANL, and then two values we have to give, destination, comma, source. Okay. So whatever the source and the destination, that will be perform the AND operation based on the truth table of the AND operations. And again, the results will be stored on the destination. So similarly, we can able to perform the OR operation. OR operation will be indicated by the O or L. L stands for the logical operation. Similarly, destination, comma, source. Similarly, I can perform the exclusive OR operations. So that indicates the syntax is X or L and then destination, comma, source. Based on the truth table only, we can able to perform. Similarly, we can perform the complement. CPL stands for the complement. And then RL stands for, we can able to perform the rotate left. Similarly, RLC, we can able to perform the rotate left with carry. Similarly, we can able to perform rotate right with the carry. So RR stands for the rotate right. RRC stands for the rotate right with carry. So these are all denoted the logical operations. Then the third type we can discuss is the data transfer instructions. Clearly, it is specified. We are going to perform the data will be transferred either source to the destination or destination to store, or either we are going to make store your data to the memory on some location, or you can able to store the data into some temporary variable. Like that, anything will be happen. Either I can able to store the data in the accumulator, or we can able to store the data in some other new location, like that. So here it all meant about the data transfer instructions. Okay, so the data transfer normally by using the move command, you can able to transfer the data from one place to another. So the syntax for the move instruction is move destination, comma, source. Up and now we can able to the source to destination, that value will be either immediate data will be moved, or accumulator content will be moved, or the register content will be moved, like that. So move a comma hash 55h. That means that we are hash in the sense we are including the immediate data hexadecimal 55 that will be moved immediately to the accumulator register. So like that, certain examples also are given. Either register to register we can transfer, or data to register we can transfer, or data to accumulator we can transfer, like that. Then move X is the another command. It is a data transfer between the accumulator and a byte from external data memory. So move X a comma at the pointer, data pointer. Okay, at the rate of the particular location from the external data memory, I can able to transfer the data to the accumulator. Push operation and the pop operation, these are all called as the stack pointers. Okay, so push and pop in the sense which are nothing but either we can able to insert the data or we can able to retrieve the data, like that. So push and the pop operation being performed. XCH, it is for the exchange. So here we can able to exchange the accumulator and the byte variable. The syntax is XCH. The fourth type is Boolean variable instructions. So Boolean variable in the sense here it is going to perform either the set operation or clear operation or complement the operations. Okay. So clear in the sense it is going to clear the values as 0. For example, suppose in the memory or in the accumulator already I have stored the data 5. Then I am going to clear in the sense everything will be reset as 0. So the operation clears the specified bit indiced in the instruction. The format is CLR. CLR stands for the clear. C stands for the carry. So it is going to clear the carry value. Set B, the operation sets specified bit to 1. CPL, which is for the complements. So the operation complements the specified bit indicates the instruction. Similarly, we can able to perform the AND operations also, OR operations also, exclusive OR operations also. These are all being called as the Boolean. The last type of instruction, which is called as the branching instructions. So normally we people knowing that branching in the sense it is a jumping of information from one to another. Okay, certain condition also we can specify. If certain condition is true, then we can move to particular statement. So if the condition is true, then we can jump into some other instructions. So jump instructions, basically it is of two types, long jump or else short jump. So long jump, it is for the term denoted as LJMP. S jump, short jump, SJMP. So L call, long call, similarly absolute call, and then either it can return from the subroutine or it can return from the instruction service routine. So here we are having conditional jump instruction or similarly unconditional jump instructions. Certain thing that we can check here. J is Z, jump with 0, jump no 0, and then we are going to decrement the jump no 0. Like that, so many jump with carry, jump with not carry, jump with the bit, and then jump with not bit, jump with carry. Like that, we can have certain things. So these are all about the different types of instruction set of 8051. Thank you.